Hello and welcome to this episode of our series on computer vision and deep learning with Python. So, in the previous 10 videos, I have shown you how to do very basic stuff with the OpenCV module in Python. And I believe you're already realizing how important it is to understand how images are represented. And like I explained earlier, I said images are just two-dimensional arrays that represent the light intensities that have been reflected by an object, okay? And so in this video, I am going to teach you the very basics of Numpy. And Numpy happens to be the de facto numerical computation library for Python. And if you want to do anything serious with computer vision, machine learning, or deep learning, then you definitely need to do Numpy, okay? And so the vision for this video is to teach you just enough Numpy so that you will be able to understand what will be taught later on and then what has been taught already. Along the way, if any image manipulation operation or deep learning technique requires that I use some NumPy technique that I haven't shown, I will take time to explain, but this is just going to be a crash course about NumPy. Okay, so I'm going to create a file. Let me say algebra.py, and then I'm going to open algebra.py. But first of all, let me activate my virtual environment, the one we created yesterday. Okay, so it's activated now, and then I have my algebra.py in here. So to use NumPy, the first thing you need to do is to import NumPy. Okay, and remember, I had to install this initially, otherwise it is not available as part of the standard distribution of Python. So you import NumPy, and there is a convention in the Python community where we give it an alias as NP so that we don't always have to precede values and functions from the NumPy module with the full-length NumPy. Instead, we choose to use NP. Okay, so I explained earlier on that NumPy is used for numerical computation and then building or creating and manipulating tensors. And mathematically, a tensor is just a multi-dimensional array of numbers that are fed into mathematical operations and are also produced by mathematical operations. And this is how the TensorFlow library from Google got its name, because in TensorFlow you basically define computational graphs, and then you pass data into these graphs for manipulations, and this data is passed as tensors, which are basically multi-dimensional arrays. So how do we create an array in NumPy? To do that, we can just say let's say arr is equal to NumPy dot array. Okay, and then you put a list in there, so I can say 1 2 3 4. Okay, and I can just print arr. So let's come here and I'll do Python algebra.py, and you can see that it is showing the array over there. Okay, I think a better way to teach this is to do interactive Python. So I'm going to start Python with my virtual environment activated, and I'll do import. Let me increase the font size a bit. Okay, import NumPy as NP. Okay, so I just said arr is equal to np dot array, and then I pass a list in there, so I say 1 2 3 4. Okay, and so when I print arr, it is an array. And then you can also get the shape of the array by saying arr dot shape. I will explain what this is telling you. Okay, so the shape of an array, if it is a multi-dimensional array, is going to give you the number of rows and the number of columns. Basically, think of these in terms of matrices. Okay, but if it is a vector is a vector could be a column vector or a row vector. Okay, so when you arrange numbers in a rectangular array along the x-axis, then you are creating a row vector, and if you arrange it along the y-axis or the vertical, you are creating a column vector. Okay, so this is how to create an array. I am going to show you how to interpret the shape as well, but let's go on. So I'm going to create a multi-dimensional array. This is actually a matrix, so I'll say met is equal to np.array, and then you put an array in there and you use another array or a list to make each row entry into your matrix. So if I do 1 2 3 4 and I come here and I say 5 6 7 8, this is creating a matrix. Let me show it, and you can see that it is a matrix made up of 2 rows and 4 columns. Okay, so the rows are read from left to right on the horizontal, and the columns are read from top to down on the vertical. So this is one row, this is one row, and this is another row. Now 1 and 5 forms a column, 2 and 6 forms a column, 3 7 4 8 forms a column. Now if I print out mat.shape, you can see that it is telling me 2 by 4. This is a tuple. Okay, so it is telling me this is a matrix or a multi-dimensional array with 2 rows and 4 columns. Okay, so I'm going to create what do we call it, a row vector or a column vector. To create a row vector, you have to do let's say vector is equal to np.array, and look at it. I have a list in here, and I'll just put a list in there again to specify the items in the row. So 1 2 3 4. Okay, and if I do vec.shape, now notice the difference between this vec.shape and array.shape. Because I didn't add these entries in a row on its own, Numpy is not interpreting it as a row vector. Okay, that is why the shape is telling you 4 by whatever is here. But if you actually want to create a row vector, then you have to remember to put it in another angle bracket or an entry for just one row in your matrix. Okay, cool. So I am going to show you how to perform some basic mathematical operations with Numpy. I'm going to create an array. Let's say a is equal to np.array, and I'm going to put in 2 by 3 by 4, and then another row has 2 by 3 by 4. Okay, and make sure your brackets, the opening and closing brackets, are always matching. And then I'll say b is equal to np.array. I'm going to create another 2 by 3 matrix here. That is going to be 4 by 5 by 6, and the second row is also 4 by 5 by 6. Okay, so I can just do c is equal to a plus b, and when I print out c, you see that Numpy has actually done matrix addition for me. So it will add the element in A and B element wise. So it will pick 2 and add it to 4, and that is how we got this 6 here. And then 3 to 5 we got 8, 4 and 6 we got 10, 2 and 4 we got 6, 3 and 5 we got 8, and 6 and 4 is giving us this 10 over here. So this is a very simple way of performing your matrix calculations. I could also have said C is equal to A minus B, and if I print out C, you can see that it has done element wise subtraction. So it is actually subtracting each element of the matrix B from its corresponding element of the matrix A. Okay, you can also do vector multiplication of matrices. What do I mean by that? I can just say A times 2, and what this does is, because matrix A, in fact let me print out matrix A, you can see that matrix A is made up of the entries 2, 3, 4, 2, 3, 4. So if you do A times 2, it will multiply each entry in that tensor or matrix by 2, and that is the result that has been printed over here. Okay, now I want to show you how to create some special matrices as well. So there is a matrix called an identity matrix. Remember, I don't want to bother you with the mathematical aspect, but I just want to show you how you can create matrices and manipulate them, because all we'll be doing with the image manipulation operations of OpenCV has to do with manipulating entries in multi-dimensional arrays of images that are represented as Numpy arrays. Okay, so that is why you need to know this stuff. We will get to the sections where I would explain the mathematics behind how the machine learning and deep learning algorithms are working, but until then I don't want to bother you. I just want you to know enough Numpy to be able to understand what is being taught. Okay, so I'm going to clear this screen, and let's say I'm going to generate, I want to generate a 3 by 3 matrix of zeros. I can just say np.zeros, and then you have to give it the shape. So I want 3 by 3, so 3 rows by 3 columns, and then let me not specify this, I will explain to you later. So if I print zeros, you can see that this has generated a 3 by 3 matrix with each entry being 0. But you can see there's a dot after the 0. This is a floating point. Okay, if I wanted them as integers, which you always want if you are dealing with images and videos, then I should have said zeros is equal to np.zeros, and I'll say d type is equal to uint 8. So now if I do this, it is going to generate a zeros 3 by 3 matrix, but each of the entries is actually an integer and not a floating point number. Okay, now let's generate a much bigger array, and I will show you how to manipulate sections of your array. But before then, I'm going to use a very simple array to show you how to select part of your array. It's also called slicing. So I'll say numbers is equal to np.arange. Arange allows you to specify a start, an end, and a step to generate numbers between the start. So I want to start from 0 to 10, increasing by 1 in each successive call. Okay, if I do this and I print numbers, you can see that it generated the numbers 0 to 9 in an array for me. Okay, let me do another example so you understand it properly. If I did 0 to 50, increasing in steps of 5, Then if I print numbers, you can see that it is generating from 0 to the number immediately before the maximum I specified here, increasing by 5. So 0, 5, 10, 15, 20, 25, 30, 35, 40, and 45. Okay, now let me show you how you can index it. Indexing NumPy arrays is just the same as indexing regular list in Python. So if I do numbers 4, then what it means is that I want to get the, guess what, which entry. It begins counting from 0. So 0, 1, 2, 3, 4 is actually going to give me the 5th item. Okay, so if I count from here, 0, 1, 2, 3, 4, and so the 5th item in my numbers array is 20. In the same way, you can change what is there by saying equal to whatever new figure you want to put in there. So I can do numbers, and when you check, you can see that the 20 has been changed to 78. Okay, 79, sorry. You can also select a range. You can select a range of them. So if I did numbers and then I put a colon here like this, basically I'm saying I want everything from the start to the finish. Okay, but I could have said I want everything from the 5th entry to the end. So you can see when I start counting 0, that is actually 0, 1, 2, 3, 4, 5. So from the 5th entry, okay, from the 5th entry to the end, so 25, 30, 35, 40, 45. So I sliced out those ones, and this is what I am getting. Okay, I could also do something like I want everything from the 5th to 8, and guess what, it is starting from here, and then it's going to give me this and then this. The way to know how many items you are going to get is to subtract the start index from the end index. So if I subtract 5 from 8, I get 3. So it is going to start from the 5th item, and then it is going to the 5th index. Sorry, if I say the 5th index, always remember that it starts counting from 0. Okay, so it is going to start from that index, and then it will put the next 3 items in there, and this is what I get. So this is it about slicing. There is also a way for you to slice from the backwards using negative indexes, but I don't want to mention that here for the sake of making it easy for people who don't have experience with NumPy to understand everything. When the time comes, I will show you how to do that. Okay, cool. So now we know how to slice on an array that is not multidimensional. It is a row vector. Okay, now let's generate a bigger array of 10 by 10 and then manipulate pieces of it and see. So I'm going to clear screen, and I'm going to say array is equal to np.zeros, and I want a 10 by 10 matrix of data type is equal to uint 8. And the reason I always choose uint 8 is we are dealing with image manipulations, and images store pixel values from 0 to 255, which is enough to be stored in an unsigned 8-bit integer. So if I print this, nice, we have a 10 by 10 matrix of zeros. Okay, what if I want to make this section, how do I select this? What if I want to select the 3rd row, from the 3rd row to let's say the 5th row? How am I going to do that? Then I can say ARR. But first of all, let me show you how to get individual items. So to identify the rows, you have to read from left to right. So this is row 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You know, I started counting from 0. If you printed the shape, it is actually going to tell you it is a 10 by 10. Let's confirm. Okay, it is going to tell you that it is a 10 by 10 array. However, let me try to change something. I'll say ARR 0, 0 is equal to 9. Let's print ARR. You see, if you say 0, 0, your first row is actually treated as row 0. Okay, so what I did here with ARR 0, 0 is equal to 9 is I'm saying the entry at the intersection of row 0, column 0, that is up down here, change that to 9, and that is the reason why this entry here is 9. Okay, what if I wanted to change this 1, 2, 3, 4, 5, 6, 7, 8, 9 entries? What I need to do is I need to specify the range of rows and the range of columns I'm interested in. So I will say ARR, and I'm interested in the start to the third, and then I'm interested in the start to the third, and I'll say is equal to 9. So let's say ARR, and then see what is happening here. So by this, what I said is select everything on row 0 to the third. So 0, 1, 2, that makes 3. Okay, so all these rows, and then all the numbers on the columns between column 0 to the third. So 0, 1, 2 is equal to 9. So it selects these sections and then it changed them to 9. You might be wondering why you need to be able to do these selections. It is very important because in computer vision with OpenCV, we usually do something called selecting the region of interest. When you are performing some manipulations on an image, there are times where you need to target specific sections of the image or the video with the operation that you want to perform. And because your image is represented as a multidimensional array, your only way to do that is to understand how to do matrix slicing with Numpy, because of course your images are Numpy arrays. Okay, so watch this video and practice and check out some resources online. You know, Numpy deserves a course on its own, and I cannot show you everything in a single video, but what I envisioned to do in this video is to give you just enough of the basics of Numpy so that what we will be learning next in the videos to come is going to make sense to you. So I hope you've understood the simple Numpy session I have had with you, and if you have any questions, leave them in your comments, and don't forget to subscribe. Thank you for watching, and I'll see you in the next video.